Okay, so lots of people get mixed up between the words storage and memory. So let's clear that up today. And let's have a look at where this is in the arrangements for National 5 computing. This is within the computer systems, in particular computer structure, and these are the two strands that we are looking at today. So are memory and storage two different things? Yes, they are. Okay, first of all, storage looks like this, and memory looks like this. A computer is likely to have up to about 2 terabytes of storage, which is huge. It's a huge amount of data that can be stored there. But a computer is only likely to have maybe 4 to 8 gigabytes of RAM. So why do we have that 4 gigabytes of RAM? In essence, it's very, very fast. And what I mean is fast access. Storage is very good at storing data or programs when we're not using them, like when the computer is switched off. But RAM is great for holding a program when we're actually using it. It doesn't process the program, that's the processor. It holds it. So what do I mean hold a program or hold data? Well, it's the equivalent of me taking a book from the shelf. I've got lots of books on the shelf and they are stored right now. I'm not using them, but I want to keep them because I will use them one day. When I actually take a book from my shelf and I open it, that is me now holding it. That is me ready to actually use it. And it's the same equivalent when it comes to a computer. A file may be stored on the hard disk, but when we actually use it, we put it into memory. A real life example of this would be if I had an essay and I was working on it today and I got to the end of the day and saved it. That is now in storage. I close down my computer and the next day I open it up, I open it from storage and load it into memory. When I can edit it, when I can change things about my essay, that is actually being changed in memory. It isn't stored until I press save. As soon as I press save, it is now in storage. I can switch off my computer and I can reopen it again whenever I want. If I didn't use memory to open up my program whilst I was using it, it would be very slow, sluggish, glitchy even, because storage is a lot slower. It has a lot slower access speeds. So by using memory, we get a very smooth process when we're actually using a program, when we're running a game, or when we are opening any sort of data. So does it mean that we should all go and buy lots and lots of memory for our computers? Does having more memory necessarily mean that your computer is going to be faster? Well, the answer is no, not necessarily. If you have 4 gigabytes of memory, then that's probably enough for the average user. Unless you're going to be creating videos and video editing or audio editing, then most of the programs that we use day to day aren't as demanding as these. If we have a very small amount of memory, then you might realise that you can't open up as many programs as you would like, or you might start seeing things getting a little bit slow. When this happens on our iPad, you've probably done this in the past, where we've got lots and lots of windows open. That means we've got lots of programs running in the background. And when things start getting slow, we flick the programs away in order to close them down. We kill them. And this frees up the memory that was being used by the programs in the background. This memory can now be used to hold the programs that we want to use, and then things should run smoother. When you switch your computer off, memory is completely wiped. There is nothing that is saved on memory when there's no power going through it. So where do all your files go? They are saved in storage. Okay, and that's why storage is given that job. It doesn't necessarily need to be the quickest in the world, the quickest access. That's okay. All its job is to save and allow us to have access to those files. When we want to actually run them, we open them or load them into memory. So what does it look like inside memory? Well, inside there are millions and millions of storage locations, each with a specific number. When a program is loaded, so imagine your game loading up again, The memory locations are filled with all of the data, the instructions, and other addresses that this program needs in order to run correctly. In order for you to actually play the game or for the game to run properly, memory then needs to have those instructions and data and addresses processed by the processor. Now, these are two separate components. So if the memory is holding it and the processor needs to process the data, then they need to be transferred somehow. And this is where buses come into this. There are two buses that we need to know about when it comes to National 5. Now, the buses allow communication to take place between the processor and the RAM. We already know that. But the address bus holds the address in RAM that the processor is accessing. It is unidirectional. Now, this means that it can only travel in one direction. That's because the signals are always going to be sent from processor. And so the processor might say, I need an address from address number 10. And the address bus will point to where that is in memory. It then might say that the next instruction needs to come from address number 515. Again, the address bus points to that exact location. The data bus carries data between the processor and memory. Now, that is bidirectional. That means it can go both ways. This means that data can transfer from the processor to memory, but it can also be transferred from memory to the processor.